Hey there, Mr. Weaver here, and this is topic 4B, lesson 1. And in this unit, we're going to be dealing with inequalities. After this lesson, you need to be able to solve two-step inequalities, and you need to be able to graph the solution of the inequality on a number line. You'll know you're successful after this lesson if you can solve simple inequalities and graph the solution of the inequality using the correct circle and arrow direction. First, let's look at the definition of an inequality. So an equation, which we've already seen, they use an equal sign to show that both sides are equal. An inequality shows that both sides are not equal. Usually that one side is more or less than the other. There are 4 types of inequalities. We have greater than or equal to, less than, or less than or equal to. First, greater than means that your variable is larger than your number. On a number line, it's shown with an open circle, and the arrow is going to be going to the right. The open circle means that wherever we put that number, it is not part of the solution. Greater than or equal to means that it's larger than the number, but it could also be equal to that number. And this is shown by a closed circle with an arrow to the right. The closed circle shows that the number where the circle is could be the answer. Less than means that the variable is less than the number, and it's the exact opposite. So open circle, but arrow goes to the left. And less than or equal to, the variable is less than or could be that number. And again, because it says the or equal to, it will have a closed circle at the number, and the arrow will go left, where the less numbers are. Finally, when we're solving inequalities, we're going to use the same steps that we did before when we were solving equations, except when you multiply or divide by a negative number, the inequality sign is flipped. So make sure you're watching out for negative signs. And finally, we're going to choose a number in our solution set to check our answer. And generally, your solution set is where your arrow is drawn. So let's get into solving some inequalities. Here I have x minus 5 is greater than negative 32. So to solve this, we would solve it just like an equation. So I would add 5 to both sides, and x would be greater than negative 27. Be careful when you're adding and subtracting, even dealing with negatives. Don't forget you are allowed to use a calculator. So negative 32 plus 5 is negative 27. We can leave the inequality sign as it is because we did not multiply or divide by a negative. So x would be greater than negative 27. Now that we have this, that is the boundary to our inequality. To show the whole thing, we're going to graph it on a number line. So the boundary would be at negative 27, which is where I would draw my circle. Because of the symbol, it's just greater than. I'm going to not color it in. I'm leaving it an open circle. And then to figure out where my arrow goes, I need to think about what x has to be. So x has to be greater than negative 27. And the greater numbers are to the right, so I'm going to draw the arrow to the right. Pause the video and solve your inequality and graph it on a number line. Check your answers. You should have subtracted 8 from both sides and got x was greater than negative 35. So your graph would be similar looking to mine, but your circle would be at negative 35 with your arrow going to the right. Let's look at another example. 114 is greater than or equal to negative 12x. The only step we need to do here to get x by itself is to divide by -12. And I would end up with -9.5 on the left and x on the right. When we're dividing, we need to remember to check to see, is it negative? Because this number is negative here, we need to remember to flip the sign. So my boundary inequality would be x is greater than or equal to -9.5. Notice, when I read it, I started with where my x was and read it according to x. So here x is greater than or equal to -9.5. So when I'm graphing it, my circle would be at -9.5. I would color it in based on which symbol was there. And because x is greater, then my arrow still would need to go to the right. Pause the video and figure out the boundary for your inequality, then graph it on a number line. Check your answer. You should have got that x was less than 3.2. You should have divided by -5, and because you divided by a negative, you also needed to flip the sign. So your final solution would look like this, where you would have an open circle at 3.2, so just barely past 3. And because x is less, the arrow would go to the left. Let's look at one last example. So here we have a two-step inequality, and we're dealing with a fraction. First thing we would need to do is subtract 8 from both sides. So I would end up with 2/5 m is less than 16. Now, to get m by itself, I would need to divide by 2/5. 2/5 divided by 2/5, anything divided by the same number is 1, so that's how we get m by itself. On the right side, we have 16 divided by 2/5. When we're dividing with fractions, remember that is the same as multiplying by the reciprocal. Okay, think about dividing fractions. Keep, change, flip. So I flipped the fraction, changed the sign to multiply. Now I can multiply 16 times 5/2, which comes out to be 40. Now, do we need to change the direction of our sign? Here we do not need to. The number that we divided by was positive, so the sign will stay the same direction. Finally, we need to graph on a number line. So my circle would be at 40. And because my variable is less than 40, my arrow would need to go to the left. Pause the video and see if you can solve for A. Don't forget to graph your solution on a number line. You should have gotten A was greater than 16. If you add 4 to both sides, you get 12. 12 divided by 3/4 is 16. Graphed on a number line, open circle at 16, and because your variable is greater, your arrow needs to go to the right. In this lesson, we learned about inequalities and how we're just solving them the same way as equations. The main difference is if you multiply or divide by a negative, then you need to flip the sign so it goes the opposite direction. Inequalities also need to be graphed on a number line to show all the possible solutions that make the inequality true. So when you're solving it, you're actually just finding the boundary, and then your arrow shows all of your solutions. So when we're graphing, greater than or equal to and less than or equal to are shown with closed circles. So if you see that line underneath, color your circle in. And that shows that your number is part of the solution. So that number works as a choice for the variable. On the other hand, if you have just greater than or just less than, you would show those with an open circle. That tells you that the number where the boundary is can't be part of the solution. And then the arrow you draw in the direction of the rest of the solutions that make it true. If you're not sure which way to draw the arrow, pick a number and see if it makes it true or not. After this lesson, do you now know how to solve simple inequalities? And do you know how to graph the solution for the inequality on a number line? If you're not sure how to do these things, go back and watch some of the examples to further your understanding for the concept. And that's all there is to this first lesson on solving simple inequalities.